All right, welcome everybody to week 3, day number 2. No, week 4, sorry. Week 4, day 2. And today we're going to be continuing our discussion of the standard template library with an emphasis on iterators today and ranges. The standard library contains a bunch of functions. It's got a bunch of containers. Containers are like data structures. The term is between a container and a data structure is slightly different. Technically, like a struct is a data structure because it holds data in a structured fashion. But in general, a data structure is something that holds lots of variables, and containers are like you could use the terms almost interchangeably if you want. You're not, although like some people might get picky if you do. So there's containers in the standard library like vectors and sets and things like that. There's functions like sort and shuffle that we talked about last time. And there are these things called iterators, which allow you to select chunks of a container to run an operation on. And so this is kind of the missing piece that we need to talk about in our discussion of the STL. And then we will be moving on to linked lists on Friday, our next big topic. So we are going to go over vectors one more time just because it's so important that we understand vectors. You would be surprised how many people are C++ programmers, and on job interviews will just be like, I've heard of them, but I never used them. And that kind of irks me because they're my favorite. Maybe not my favorite, but like they're my most used data structure. And if you're going to be working in C++, you really should be using vectors and not arrays. They were added to the standard in like 98 or something like that, so you've had 24 years to get used to it. It's no longer the 80s or the 90s. Stay up to date. So what's my favorite one? Hash tables. The unordered map is probably my favorite one, just because of it's the fastest. It's basically what it comes down to. So anytime you see like an input test where like your thing's timing out, like you're passing all the input tests, but like it's just too slow, like you should be like, maybe I should use an unordered set or an unordered map or something to speed it up. Switching out the data structure you use is oftentimes the key to getting your code to run fast. It's a very easy optimization you can make when you use the standard template library. Like we saw last time, like you could switch vector and deck, and all the things still work. It's just now with a deck you can push and pop off the front in order one time instead of order n time. So unordered maps, I guess, would probably be my favorite, even though it's technically not a very well implemented hash table. There are faster implementations out there. If you really like speed, Electronic Arts has their version of the standard template library called the EA-STL that are data structures that are sort of optimized for running time and speed and memory constraints and not doing excess news and deletes and things like that. So you can look into that. It's called the EA-STL if you were curious. So vectors. They're my go-to default. Like when I need to hold a lot of things, I just start off by making a vector and I stick with it until proven otherwise. In most cases. Sometimes I know right off the bat I'm going to need a hash table or something. But a lot of times, like if I'm just like keeping track of some numbers or something, I'll just stick it into a vector, and then when it gets too slow, I switch it out for something that'll make it faster. So your basic 3 operations on a vector are .at, which grabs you the ith element of a vector. Remember, vectors start at index 0, so the first element of a vector is element 0, .at 0. The .at 1 is the second element. So off by 1 errors are very common in computer science. That's one of the reasons why I recommend you use .at instead of square brackets, so that you don't accidentally go out of bounds on one side or the other. It will catch it and tell you you're dumb. And you say thank you very much because you really want to be told you're dumb rather than being dumb and not knowing it. It's like one of those Zen koans. Is it better to be dumb and not know it, or to be dumb and told it? And it's better to be told it so that you can fix it and not be corrupting memory and stuff like that. Way worse to not know. So that's how you read and write to a vector. .at, simple. And if you want to add to the vector, vectors really only should be added to and deleted from at the end. If you are constantly erasing things from the middle of the vector or the beginning of the vector, you're probably using the wrong data structure. It can happen. Like if you do it occasionally, such is life. But in general, you only want to push back and pop back. So push back grows the size of the vector by 1 and adds the value you put in there, x, it adds that to the end of the vector. So if you push back 10, it adds the number 10 to the end of the vector. And if you pop back, it deletes the 10 that you just put in there. Okay. And dot size will tell you how many elements are currently in the vector. And these three things are basically all you need to know for most use cases. So you can initialize the vector using curly braces. It's called universal initialization syntax. And this works with basically every container that I can think of off the top of my head. You can initialize it with a set of values that it starts with. And this is true for sets and everything. You can always use curly braces. There's probably some examples that violate that rule, but every one that I can think of, you can give it a set of starting values. And sometimes you do have starting values. Like if you're doing the Fibonacci sequence, you would start with 1, 1, right? In the Fibonacci sequence. Because if you start with zeros, then it doesn't work, right? So sometimes you do. A lot of times I don't. Sometimes you do. And so if you see out vector.at1, after initializing it this way, it's going to see out 64. Because 64 is index 1, or the second element in it. So what are the negatives of deleting? It's slow. Yeah, if you do it occasionally, order n isn't going to break the bank. It's not going to take until the heat death of the universe. And I'm out of focus. Look at this. What is going on with you, huh? It's so annoying. I clean the lens and everything. It just doesn't want to focus on me. Oh well. So pushback grows the array. So if you have 9, 6, and 2 in the vector, and you add 99 to the end of it, it's now 9, 6, 2, 99. If you want to make a vector of size 10 right off the bat, this makes a vector of size 3, but you don't need to specify the 3 here. That's nice, right? You don't actually have to count how many things you have on the right-hand side here. You just say make a vector and initialize it with this, and it makes a vector of size 3. This will make a vector of size 10 with all the values set to 0. And if you put a comma there and put like 99, like 10 comma 99, that'll make 10 99s. So you can initialize a vector with values other than 0 if you would like by putting in a second parameter to the constructor. And here we have 10 zeros followed by a 42. So if you output the size after that, it'll be 10 zeros and a 42. Size 10, or size 11. 10, and then you added 1, so it's going to print out size. The size of the vector is 11, and it contains 10 zeros and a 42. Okay. So, typically, though, this is how I do user input. If I'm reading from a file, if I'm reading from the keyboard, in real life, you don't usually read from the keyboard. That's more of like you're in college and you're learning how to program kind of thing. For real programs, you launch your game is going to open a file, and the file's got all the data for your Pokemon or whatever in it. You don't enter the stats for Pokemon every time you play Pokemon. It loads it from disk. But it doesn't matter. This is the same code pattern that you'll follow for reading from a keyboard or reading from disk. You just would switch out CN for a IF stream, right? You'd go IF stream ends, file.text, and then inside of here this would be ends instead of CN. And then you'd read from a file until, in this case, you get to 0, or you hit the end of file. So what this does is you start with a vector of size 0. This is how I do it most of the time. Because I don't know usually in advance how many Pokemon there are. Like I don't want to hard code into my code that there are exactly 151 Pokemon. Because what if, we release a DLC and there needs to be more? Now I'm toast, right? So I usually just start with a vector of size 0. And as I read one Pokemon at a time from disk, I use pushback, and that grows the vector to fit however many elements I need. It's a very simple and elegant way. It doesn't waste too much memory. Secretly behind the scenes, a vector might over-allocate up to twice as much RAM as it needs. So if you have a vector of size 1,000, it might have 2,000 things secretly allocated. And the reason why it does that is because whenever you push back into a vector, if there's no room left in it, then it has to make a new vector, and makes a new vector of twice the size, and it copies all the elements over into the new one, and then it puts the push back, whatever into the new slot, and then all that stuff there, it doesn't appear. Like you won't see it if you call like vector.size. Like if we have if you want to draw it out, if you have a vector containing 4 elements, 10, 20, 30, and 40, and man, that is a bright red color. Now, let's say we push back 50 and we're out of room. So what will happen is it will allocate a new vector of size 8, and it will copy the 10 over. Now, this is an order n operation, but it only happens 1 out of every 1 over n times. So it works out to amortize order 1 time. Amortized means averaged over time. And then we would put the 50 in here. And now we would have these things allocated. But if you asked the vector at this point, you're like, hey, what is vector.size? It would say 5. These things are secretly like reserved, they're in memory, but the vector, for all intents and purposes, will just be like, no, there's only 5. There's only 5 people. And then when you push back 60, it'll just go into that open spot. Push back 70, it goes into the open spot. You push back 80, it goes into that open spot. You push back 90, now it's got to allocate twice as much, and it's going to copy all these guys over and then put 90 into the new spot. So if you want to do a nice little optimization for your code, you can actually tell it how much memory to reserve. This is like what we call like the reserved memory. It doesn't appear. Like if you do .at, like if I tried doing a .at and accessing that memory there, it would be like, nope, you're out of bounds. Like it for all intents and purposes, it's not real. Like it's not visible. You can't .at it. You can't, if you say .size, like it doesn't exist. But secretly, it's reserved that memory so that you don't have to do this really expensive order n copy every time you do a pushback. And the only time this comes up, it's because it's an ADT, right? An ADT means it is an abstract data type. It hides from you the implementation details. So we could do this if we'd like. So this is a nice optimization. This thing here, you're not going to notice any difference in your code. What this tells the standard library though is like, I'm expecting roughly 1,000 people, and so it'll allocate a vector big enough to hold 1,000 people, 1,000 integers behind the scenes. It just increases the size of that reserved memory so that you don't have to constantly be copying out and deallocating, new allocating and copying and deleting, new allocating, copying, deleting. If you know roughly the ballpark of how many batter ups you're going to be processing for Major League Baseball, you might have some rough idea. It's 30,000 at bats per year. I don't know. This literally won't affect the correctness of your program at all, because if you run out of the reserved memory, it just grows the vector anyway. It's just like kind of like a little optimization thing, and you'll notice a good runtime increase if you reserve the memory in advance. That will stop you having to do these expensive copies every so often. So that's one of the ways that I've been able to beat you guys on some of these running time things, is I will secretly, rather than, like I'll start with this is an empty vector, right? Even after I reserved 1,000, if I counted vector.size, it'll be like 0. It's just secretly, making room so that it avoids copies. And sure, like you might waste a little bit of RAM, but this is 4K of RAM. It's not a lot of RAM, even if you're going to do like 100,000 integers, that's 400K of RAM. Who cares? My system has 32 gigs. Like,
are you going to tell them about? Oh wait, no. This
is CSCI 41. Yeah. Yep. So if you push back 1,001, then it will reallocate. Yeah.
Daddy,
so this doesn't affect
this video game class.
That'll be tomorrow. Yeah. So this doesn't affect the behavior that you observe at all. It's just kind of a clue. Start with this much memory reserved, and you'll notice maybe an increase in running time, and that's about it, at the cost of RAM. So it's a trade-off between using more RAM and better running time. And you usually want to set it around the number that you expect to see. Okay. If you make it 100,000, you use 1,000, then you've wasted 400K of RAM. Yeah, like I got 32 gigs, like it's fine. Back in the day, back in the 70s and 80s, RAM cost $1,000 per K of 1970s money. $1,000 in 1970 is like, I don't know, a lot of money now. Like 5,000 probably today. I don't know. 1 USD in 1970. It's 7. Wow. Yeah, look at that inflation. Yeah, it's fantastic. Okay. So, yeah, so that'd be like $7,000 for 1K of RAM. And so if you upgraded the 4K RAM package, that's $28,000 today. That's like a car. And so people back then cared about every single byte you use, you know? Like you gotta fight for and justify every every memory allocation you do. Nowadays we're like, just throw an extra gig at it. Who cares? You know, turn the light back on, please. Is that more efficient? What GPU do I have? I have a 3090. Ada, lights on, please.
Lights went out for some reason.
Is that more efficient than initializing 1,000 values to 0 and overriding them as you go? It just pre-allocates the memory. It doesn't do anything more than that. It just stops you from having to do those new copy and deletes that happen behind the scenes, which can take time. A gigabyte of RAM should do the trick. Yeah, exactly. Nowadays we're like, should I buy 16 gigs or should I buy 32 gigs? Like, I don't know. Like, you know, how much am I even using right now? So here's all my cores, you know, memory. I'm using 11 out of my 32 gigs. Like, I'm not even close to running out of RAM. You know, I'm using 37%. But if I had bought 16 gigs, I'd have been fine. You know. And this is with me streaming on Discord and on OBS. And I've got PowerPoint running, and I've got a terminal connection, and I got a bunch of Firefox tabs open. You know, it's 20 gigs that are just kind of hanging out, not doing anything. So we live in a different world now. When people invented DRAM, that was a game changer because that made making RAM inexpensive, and you could basically print a RAM. Like how you make a CPU. You literally just print RAM, and as they figured out how to make the sizes smaller and smaller, the RAM got more and more dense, so you got more and more RAM capacity, and the price of RAM plummeted after they figured that out. Okay, so when does a vector run out of room? It never does. You run out of room when your system runs out of RAM, basically, which can happen. Like, you know, it's not infinite, but it's a lot. You'll run out of RAM if you have an infinite loop. Let's put it that way. Yeah. Okay. So if you want to print a vector, you just say for every integer x in the vector. This is called a range-based for loop, or sometimes a for each loop. For each integer in the vector, print out that integer. I like using x instead of I in my for each loops or range-based for loops because i's are typically used for like indices. So like vector.at_i means index 5 or index 10. You know, that's not the value there. That's, you know, the location, not the value. Do you guys understand the difference between a location and a value? Like my address is 1234 Main Street, but I'm the value. No, my daughter's the value. Okay.
What?
So there's a difference between an address and the value at that address. So I is like the address, and then I use x for the value. So that's every value in the vector. Okay. Programs are so inefficient now and it bugs you. Yeah, to a certain extent. But at the same point, like, it's just kind of nice being able to like throw RAM at a problem.
Tell us about Hedgehog World anyways.
No, sorry, Carl. I got a lecture.
Did you know about your class of an Unreal Engine?
Yeah, I do teach game development. So for those of you that don't know, IS50A is first semester game development. IS50B is second semester game development. And it gives you an opportunity to not only learn about games and as a science, the science of ludology. Ludos is the Latin word for game. You also learn how to make games, and it will probably improve your programming skills as well.
Tell them about Hedgehog World now.
My daughter wants to make a game with me now called Hedgehog World. Okay.
No, it's much more than just a game.
Much more than just a game.
And just to answer your question, no, it does not have Sonic the Hedgehog in it.
All right. So, Yeah, so this range-based for loop prints out all the elements in the vector. This prints out all the elements in the vector, but it also prints out the index. And so if you ever need the index, like vector.at 5, double left arrow 50 or whatever, then you have to use a regular for loop. Okay, so regular for loops are useful if you ever need the index, if it matters to you. At location 3, we have the value 30. At location 9, we have the value 90. So with this, you don't, whenever you print x, you don't actually know where it is, right? It's just somewhere within the vector. It runs over the entire vector. There's no indices. And the nice thing about having no indices anywhere within this line is you can't go out of bounds, right? You can't go past, one edge or the other. If you want to modify a vector, you have to use a range. Well, you could use a regular for loop, of course. But if you want to modify a vector, doubling all the values in it using a range-based for loop, you have to use call by reference. And so you would have to say for integer reference x colon vec. X times equals 2. And so if you do this, this will double every value in the vector. Very simple, very easy. It's not, it's a very compact way of just saying double everything in the vector. I like it a lot. But yeah, don't forget, if you forget the ampersand, then what happens is it will copy value. It'll be called by value, right? And so it copies value out of the vector, it doubles the copy, and it throws the copy away, which is absolutely pointless. You just wasted all this time and did absolutely nothing. So you want to use call by reference with this. If you want to delete the last element, oh, by the way, if you wanted to print the last element of a vector, vector.back prints the value of 5 here. If you want to delete the last element in a vector, you use popback. So we typically only use pushback and popback to add or insert or delete things from a vector, because that's where it's fast. Vectors are fast at inserting and deleting at the end. They're slow everywhere else, and by slow I mean order n. So if you want to delete something from the beginning of a vector, then you remove it from the vector, and then the element to the right has to move 1 to the left, and the element 1 to the right of that moves 1 to the left, and then if you have a million elements, then you have to shift a million elements over, and it's annoying. It's really annoying. So if you delete from the end, it's order 1. It's a single operation. You can think of it that way. So if you call popback, that'll delete the 5, and then if you print out the thing, like x instead of I here.
Daddy?
Switch that to x.
What's that?
That's a hedgehog.
Wait. Oh, that's so cute.
So the people at home can see it.
It's so cute. I feel like I want a hedgehog now.
Yeah, we'll talk to our friend Natalie who owns hedgehogs about it.
I went to Hedgehog Cafe. I didn't really spend much attention to the hedgehog. I spent most of the attention on my hot lemonade.
Okay. Hot lemonade, interesting. Okay. So, all right. So this is all stuff you probably should have known already, but I'm just reviewing because it's really important to know how to do stuff with vectors. Now, to delete an element from a vector, any element, not just the. Do I have that in here? No. We'll get to it. Okay, so if you want to find an element in a vector, you can use the find function. It's in hashtag include algorithm. This searches through the vector to find whatever value you're looking for. So we see in target, we see in like 40, and then find is going to go through the vector until it finds the number 40, and then it returns a iterator, which is something kind of like a pointer. In fact, I'll call them pointers sometimes because they do point at things. But they're a more powerful version of a pointer, kind of like how a vector, vector array is to vector as pointer is to iterator. Okay. You guys kind of understand? Like, an iterator is kind of a pointer, and pointers are kind of iterators. In fact, they can be used interchangeably sometimes. But they do more. There's more stuff you can do with an iterator. Well, just like there's more you can do with a vector than an array, even though they're kind of conceptually kind of the same thing. Okay. So you'll end up with so if I typed in 40 here, if I typed in 40 for the target, find says starting at the beginning, going to the end of the vector, search for the number 40. And it's going to return an iterator. Note that I didn't use the type here because the type is vector colon, vector, angle bracket, int, close angle bracket, colon, iterator, which I don't want to type and doesn't really fit onto a PowerPoint slide. I just use auto. Anytime I use iterators, I almost always use auto. And in fact, I think the auto keyword was introduced because the iterator type names are so stupidly long. It's like dumb. So it returns a pointer or an iterator to this element here. If it doesn't find the thing it's looking for, it returns a pointer to the end of the vector. Now, a lot of people think this is the end of the vector. It's not. The beginning of the vector, vec.begin, is in fact pointing at 10. But the end of the vector is actually pointing here. There's a special sentinel value. You can think of it as like one past the end of the array, and that's end. And so with switching end and begin, search and reverse, it would not. It would in fact not work. If you want to search in reverse, then you can use reverse begin and reverse end. Our begin and our end, or rend, which sounds cool. Claw, bite, rend, is if you want to go through the vector backwards. And in fact, if you want to sort backwards, you can sort backwards using our begin and our end. And then it will sort it greatest to smallest instead of smallest to greatest. Hey, cool. Easy peasy. So yeah, so for this function, you're finding between this point and this point, not including this point. That's how, we're about to talk about ranges, but that's how ranges work. You give a pair of iterators, and it searches in that range, not counting the last spot. If it can't find it, it returns a pointer to here. So if you were searching for 70 or 100 or negative 20, it would return a pointer at this special sentinel spot here, vector.end. That's why it can't be pointing at 50. If it was pointing at 50, you wouldn't know if you had found 50 or if it meant not found. Okay. So if it returns a pointer to vector.end, which again is one past the end of the vector, then that means, sorry, I couldn't find 420 within your vector. If you did find it, then, and you want to print out the value there, I mean, technically you just print out target, right? If you want to print out the value, you have to dereference the pointer. You have to dereference the iterator, okay? So if you get a pointer pointing at 40, you have to say star it, and star it is the same thing as 40. Okay, so this will print out 40. It's the thing it's pointing to. It dereferences the pointer. So if you find it, you can print out 40s in the vector. If you couldn't find it, it's going to print out 40 not found. And instead of star it here, I could have used target because it's pointing at 40 and we were searching for 40. So they're more or less interchangeable. That said, sometimes you're going to search for things based on a keyword, like if you're searching through a database of people that have a name, address, and social. You might search through it using find, looking for a name. And when you find it, it returns a pointer at the entire record. And then you can dereference the record and be like, iterator points to SSN, iterator points to address. Notice that it works exactly the same way as a pointer. So they're not the same, but conceptually they're kind of interchangeable, kind of. Okay, their iterators are just more powerful than pointers. They're a class. They're not a primitive type like pointers are or arrays are. They do more, but you can kind of like the syntax is the same. Right? So you can print out iterator points SSN, iterator points to address, iterator points to name if that's what you were pointing at. Okay. So any questions about find?
Daddy, what does it mean to have a rolling bell?
A what?
A rolling bell.
I don't know what that is. What's a rolling bell? I don't know. Any questions about that? Searching? Useful. It's very useful stuff. Nope. Yep. Nope. Not good. So let's talk about ranges. So a range is a pair of iterators. Okay? And you will hear the word range appear a lot in the C++ documentation, like a range-based for loop, right? And so by default, like if you want to just operate over the entire vector, or and this goes not just for vectors, but for any of the containers. All of the containers have iterators on them, and that's what makes them so wonderful to work with. Is that even though a binary search tree is laid out like this, and to like print out all the elements of it involve like going down this way and this way and up this way and this way and this way, if you have a iterator to the beginning, and you have an iterator to the end, which is like a sentinel value here, The same code to like search through the binary tree or to print out all the elements in the binary tree work exactly the same way. You just switch out vec with like your set or whatever it's called, and the same code would work. That's what's so beautiful about the design of the standard library, is that they've got containers that all return iterators, pointers like, to the beginning and the end of it. They have algorithms that take iterators, and iterators usually come in pairs. Here's the beginning we want to work on, here's the end we want to work on. And if you want it to cover the entire data structure, you just pass in beginning and end. And so this code could find something in a vector, it could find it in a linked list, it could find it in a deck, it could find it in a hash table, it could find it in anything, any of the standard library containers. And it's really nice. And so that's the beauty in the design and the sophistication of the standard template library, is that it allows you can almost just swap out, like, I don't know if vec is my right choice. Let me put it in a deck and benchmark it and see if it's faster. You literally change one word, vector to deck, and then you rerun your timings. You're like, oh, look, it's slower. Okay, let's put it back. It's and below the scenes, like, what's going on is a very different story. Like, a vector is a linked list of arrays. So like what's happening underneath the hood is actually quite different. But because of this use of ADTs and interfaces and things like that, separation of concerns, you can actually write code that's very simple, very powerful, and works the same way for very different data structures. Okay, so beginning and end will give you the whole data structure, but what if you just wanted to search through the first three elements? Math works with iterators. So you can add to an iterator. An iterator can also do this. You can do iterator plus plus, and that will move, like if you have a vector and the iterator is pointing at this guy, and you say iterator plus plus, then it will now point at that guy. So plus plus just points at the next thing in the iterator. Iterator minus minus will make it point at the previous one instead. And you can do arithmetic with it. So you can say from the beginning of the vector to the beginning of the vector plus 3. So vector.begin is that one. Vector.begin plus 3 would be 1, 2, 3. And so this would select the first 3 elements of the vector. Not this one. Vector.begin plus 3 that we're pointing at, this one, is not part of the range. Remember, the ending one is not included in the range. It's called the half open pattern. So like anytime you have a for loop, right? You have for int I equals 0, I is less than but not including the size, right? Let's say that's 5. It says starting at 0, going up to but not including 5, going up to 4. It's the same pattern. That's why I teach you guys this way of doing for loops, because it matches exactly how ranges work. Starting at the beginning but going up to but not including the end. Remember, the end is off the edge of the vector. We don't count that one. We don't talk about Bruno, right? So if you pass in vector.begin and vector.begin plus 3, vector.begin plus 3 is not included in the search. It only searches through the first 3 elements, 0, 1, and 2. Okay? It's the exact same pattern as the for loop. So this says starting at 0, going up to but not including vector.at 3. Okay? So this is going to search 0, 1, and 2 for the target. And if it can't find it, it doesn't return vector.end. It returns this. Okay, and I'll show you an example of how this works. So if it can't find it, it returns that. So whatever the second parameter you pass in, if it can't find it, it returns that, meaning not found. So if you had 10 and 20 and 30 in here, and you searched for 100, it would return a pointer at this one right here, which might have 40 in it or something. So you never want to dereference vector.end or any of these things. You check, right? You do this. You always check to see if the iterator returned was the second parameter. That means not found. Okay. So it limits your range. There's no limit per se. It's just whatever you want. Like if you want to shuffle the first half of a vector, you can do so. You can say from vector.begin to vector.begin plus vector.size divided by 2. Random shuffle vector.begin, comma, vector.begin plus vector.size divided by 2. That'll shuffle the top half of your deck. Okay. And all of these things we've been talking about, like find and shuffle and all these things, they take ranges. And that chooses the part of the data structure that you want to shuffle, or that you want to search through, or you want to count, or find the max element of, or the min element of. So let me give you a visual representation of it. This is the red arrow. I stole this, by the way, from hackingcpp.com. So the blue arrow is, it's called academic freedom or something. I don't know.
Oh, I thought you said hacking.
Yeah, hackingcpp.com. That's the name of it.
Oh, I thought you said you hacked a program.
No, I didn't hack anything. I have a hacking cough. No laugh. Okay, fine. It wasn't funny. So blue is begin, red is end, right? Here's begin, here's end. And so if you want to search through the whole vector, like if you want to call find on this thing, you would pass in vector.begin, vector.end, and it's going to search through the whole thing, 0, 1 through 5. Right? End is pointing at 6, and so it's like less than end, right? Does that make sense? Like, it's just like with a for loop. When you say for int I equals 0, I is less than 10, I plus plus, it goes from 0 not to 10, 0 to 9, the one before 10. And so that's the hardest thing with ranges, is that is not included within the shuffle. Whatever you point to with the second parameter is not part of the shuffle or the find or the min element or whatever it is you're doing. Okay. So if you start at begin plus 2, it'll be element 2, and you go up to, but not including begin plus 5, it'll search through 2 through 4. Okay. This will search from 2 to 2, and if you pass in an empty range, it won't do anything at all. Yeah. Crickets, I know. My daughter's my worst critic.
What? Did I just hear something?
I said you're my worst critic, girl. I tell all these fantastic jokes about having a hacking cough. And no, it's actually a terrible joke. It's fine. It's best for you not to laugh. Okay.
What?
It's best for you not to laugh.
Why
You
not?
need because it wasn't funny. So, that's why I send you to clown school. So you can learn the true meaning
Clown
of.
school wasn't very useful. Clown school was just playing stuff.
Hey, do you want to show them a pratfall?
There's no yoga mats.
I thought I was sending my daughter to an improv class. It was with a Fresno Children's Music Theater. It wasn't an improv class. It was a clowning class. So they learned the basics of clowning. Developing a clown persona. Yeah. I showed up on the first day of school and I was like, oh.
What?
I didn't know I was signing up for a clowning class, girl. I thought I was signing up for an improv class. Improv is improvisational theater, where you go up on stage and then they'll be like, all right, you pretend you're a fish, and you pretend you're a fisherman, and go, and you have to like do some sort of comedic skit. It wasn't. It was clown school. Okay. So.
Yeah, you weren't teaching us anything.
Huh?
Except clowning.
They did. Yeah.
And they barely taught us anything. You only taught us one thing per day if they did any.
Well, it'll prepare you for a life in politics, girl. Let's put it that way.
No, it won't. I don't want to be break falling a day of an election.
Honestly, if a politician went up there and pratfalled like whoop, and fell over and I don't know.
I don't know how many.
I'd probably
vote
vote for him.
person.
I don't know. Maybe not.
Why?
I don't know.
Why would you vote for him?
It'd be different. It'd be a little different. Okay. So. You know how I said there's vector.begin and vector.end? There's also vector.rbegin and vector.rend. So if you want to go backwards, these are reverse iterators. So reverse iterators...
These are very disappointing photos I have to get.
If you had like an iterator here, and if it was a normal iterator, iterator plus plus would be this one, right? If you said iterator plus plus, it would be here. With a reverse iterator, if you had a reverse iterator pointing here, iterator plus plus would be this way. So reverse iterators, every time you add to them, they go backwards. So rbegin plus 1 is this one. Rbegin plus 2 is that one. And they're mostly useful for like if you want to print out a vector backwards, like that's actually kind of useful, right? So, you can use it to print a vector backwards. If you want to sort backwards, you can do that. No, this is your next homework assignment. Let's see. So if you have a vector here full of 10 through 20, you can just sort it backwards using rbegin and rend. There's other ways of sorting backwards as well. You could pass in a custom sort algorithm, a custom sort function. You can use stood greater. But that's honestly the easiest way of doing it. So if you run it, you just sort it backwards, greatest to smallest. And then if you want to print a vector backwards, you can use this. So starting at r_begin, going to r_end, one at a time, print the value there. This is a common code pattern some people use. Some people really like using iterators to do for loops. I don't. I just use regular for loops and range-based for loops. But depending on, if you go to a company that likes iterators, they will have code like this, where it says starting at the reverse beginning of the vector, going to the reverse end of the vector one at a time, it prints out the value at there. And so if you look at the code, we sort it greatest to smallest, then we print it out backwards. And we reverse it in order O time. O0 time, right? Because you're reversing a vector without even doing any operations at all. So we were talking a little bit in the previous class about job interview questions, and for whatever reason, a lot of tech companies like having people reverse stuff. And a friend of mine applied for a job at Facebook, and they had him reverse the linked list. I don't know why tech companies are so fascinated with reversing things, but if I was a employer, I would want to see somebody like just use this, or if you wanted, you could call reverse vector.begin, vector.end. And so that, because it's already sorted, right? This will reverse reverse the vector. So I would want to hear a prospective employee be like, hey, can I just use stood reverse? I'd be like, I'm glad you like that, because I don't want to pay somebody to write code that's already in the standard library, right? I want them to use the standard library so that if I'm telling you to make a game, the code that you're writing has to do with the game and not like reinventing the wheel. Thank you, girl. Like people that don't know the standard library do. That's why I go through this lecture, is so that you become a more productive and more like you write code quicker, your code runs quicker, it's less buggy, you can get parallel performance out of it. There's a lot of benefits. Killing my tablet here, girl. So okay, so yeah, so reverse end is useful for sorting backwards.
It doesn't have a life.
The only reason you should ever rewrite is if you need a faster implementation. True. And a lot of times, though, the standard libraries implementation are pretty fast for a lot of things. Like, there's a lot of nerds that have spent a lot of time like really trying to squeeze every bit of performance out of very boring stuff. Like, add up all the elements in a vector, right? So, like, if you wanted to add up all the elements in a vector, you could let's just code graveyard this thing here. So we got, let's make it a little, whatever. Okay, so you could say for every integer in the vector, sum plus equals that integer, and sum equals 0, see out the sum. You guys with me? Like I could write code to sum up a vector of integers really fast, right? Like this took no time to write. You guys feel me on this? Like, why would I use a standard library function to do this when I could just write it?
Daddy?
Let's see if it works.
This is very
150.
confusing.
Okay.
Daddy, this is very confusing. One of the articles say that Mission La Puricina didn't have they didn't discover a bell tower, but in another paragraph it says that bells would ring to signal lunch.
Yeah, I think they knew that there was a bell there. I think they just didn't know where it was, because it was reconstructed by the CCC back in the 1920s and 30s, something like that. So you guys can see here that there's a function called accumulate. Accumulate adds up all the values in a vector, right? And maybe it took me longer to type that than it did for me to use the range-based for loop. So what's the difference? Well, there's 3 benefits to using the standard library here. First benefit is it expresses intent to the compiler. right? So like, it knows what you're trying to do. It knows if you use a call to accumulate, it knows you're trying to add up all the values in the vector, right? Whereas when you have a for loop, it has to kind of infer what it is you're doing from your code. And that's a harder task for a compiler to do. They're not AI, you know, like they can, like optimizers are pretty good, but they're only human. The third parameter is the starting value. That's the subtotal to start with. I think it should work with this, like, frankly. I think that should work, but it doesn't. You have to provide a starting value of 0. So, it's kind of a personal pet peeve I have with accumulate, that it requires that. So maybe it's because like if you do that, it'll do like a double accumulate, like it'll use doubles instead of events. I don't know. There's probably a good reason for it. Okay, so the first good reason why use accumulate. Well, the typing is about the same, right? It's about the same amount of typing to do this because we had to make a sum, and yeah, it's probably about the same amount of typing. It's not really a win there. 2 is there's often some clever tricks that can be used to speed it up. So for example, AVX 512, right? So AVX 512, which is enabled on some Core i9 CPUs, not the Alder Lake ones. The 12th generation Core i9s have AVX 512 circuitry built into the chip, but Intel disabled it. And so some people figured out how to turn it on and found that it was actually quite fast and lower power than having it off. But then Intel released a firmware update to disable it again. I have no idea why Intel would do that. My only guess is that it was buggy or something. Or it frankly baffles me that they put it into the chip and not let people use it. Because what AVX 512 is, it allows you to do 512 bits of arithmetic at a time, if you want to think of it that way. So it might be a security issue. I don't know. Like it's baffling to me because it's pretty cool. Like a 32-bit integer is a normal int. 32 times 16 is 512, as Mincarelli figured out in the previous class. So with AVX 512, you can actually add 16 numbers together in one operation. That's cool. 16 times faster than doing it one at a time, right? And so if you're doing accumulate, the people who wrote accumulate could very well say like, hey, if your CPU has AVX 512 support on it, do 16 adds at once. Cool. Just a free 16-time speed up in performance. And there's there's smaller versions of that as well. You'll learn about it in CSCI 45. Every modern CPU can do at least 4 adds at a time, right? So, and that's because in 3D games they're 4x4 matrices. So, 4 is there for a reason. Third reason is if you pass in a parallel execution policy to it, then and you've got multiple cores on your system. Like my machine here has 10 cores and 20 logical. So it pretends to be a 20-core system. It's really a 10-core system. And so that essentially means that I've got 10 different CPUs on my computer here. And so if you pass in a secret parameter here, it's not really secret, but a hidden parameter here at the end of accumulate, you can pass in a parallel execution policy and say like, hey, if there's multiple cores available, use them. And now, because you're using accumulate instead of this, and for something simple like this, there's a pretty good chance the optimizer will figure out what you're doing and maybe generate the same code. Maybe not, because it probably won't do anything in parallel unless you ask it to. It might do this. It might, there's ftree optimized, like there's flags for the compiler to try and figure out this thing and generate parallel adds and things like that. For this, it probably won't. The optimizer doesn't use multiple cores by default. And so if you were to be accumulating across like a billion integers, it'd be really nice if you could do 16 at a time on all 10 cores. So you could be like, use all 20 cores, you know. And then it'll run 20 times faster just for free. You know, you don't have to learn, you don't have to take a parallel processing class. You don't have to learn OMP, which is the easiest parallel processing environment. You don't have to learn MPI or any of these things. You just be like, hey, yo, make this parallel for me, and it will. So that's why we like using standard library functions, even when it's something simple like accumulate, where it's just like adding up everything in the vector. And that's what I'm looking for when I'm hiring people too, by the way, is like, do you know the standard library? Do you know what a vector is? Do you know how to use ranges? Do you know how to use accumulate? You know, things like that. And there's a lot of really advanced stuff, but I just want to see people that are familiar with it, because that means they're going to be writing code that has to do with what I want them to write, you know, the application we're writing, and not wasting time doing stuff that already exists, because then I'm paying them to just write a worse version of the standard library. So, but Walker, all about that speed. Yeah, so Walker did make a point. Like, sometimes you'll write your own stuff if you can make it faster. Like, after you've benchmarked your code and you've profiled it. For example, in CSCI 45 right now, they're learning about profiling, and well, let's not get too far off topic. But basically, you can generate coverage reports and profile your code and see what lines of code are running more often than others. Yeah, maybe you can find the hottest, tightest loop in your code that runs millions of times a second, and you're like, all right, that I need to focus on. And if it's the standard library slowing you down, and you can come up with a better implementation than the standard library, then do it. You know, it's not, you know, standard library has to be general purpose, you know, and a lot of times you can find a faster solution, especially if you know stuff about your data that they don't know, right? Like, if you know that your data has to all be numbers between 1 and 100, like, there's a lot of algorithms you can write that can leverage that knowledge you have, that it just can't possibly know that, to get huge orders of magnitude improvements in speed. So, but usually you don't optimize until you've been convinced by profiling your code that you actually need it. Most of the time, you just use a standard library, just leave it with that, and if it is slow, then you start investigating why. Okay. But really just use ESTL, yeah. Use ESTL to begin, and then if you need speed, then you can investigate alternatives later. Or you can use something like the EA STL. Right. It's on GitHub, you can look it up. And they have faster versions, a lot of the stuff in the STL. Okay, yeah, so we went over reverse iterators. Okay, so let's come back into the PowerPoint presentation. All right, so so this is a very common loop that you'll see people use with iterators for people that love iterators. There's some people that just love iterators and use them all the time. To me, they're kind of like, you know, like, but this pattern here, starting an iterator starting at the beginning, going to the end, but not including the end, one at a time, scouting the values in it, or you can do other things with it as well. This is a alternative to your regular for loop, and a lot of people like this. And you use this usually not with vectors as so much as like with sets and things like that that don't have a .at operator, right? Because you can't do this with like a set, because there is no element 5, there is no element 10. But you can do this because they do have iterators on it. Muya just got a job at Microsoft, and his job interview question was, from a range of a binary search tree, find all values that are between 2 numbers. And that's what got him hired at Microsoft.
Binary?
Binary means 2. So, for example, when you say people are coding in binary, there's 2 values possible, 1 and 0.
Why aren't there... How come only 1 and 0 are there?
That's it. If you have ternary, there's 0, 1, and 2. For octal, there is 0 through 7. For hexadecimal, there's 0 through 15. For decimal, there's 0 through 9.
But decimals are a period.
Decimal is what you know. Yeah. Okay, so Moya is a smart.
Decimal is 10. Dec?
Yes, deci, 10, yeah.
Okay.
Huh? So our normal, we use base 10 because we got 10 fingers and toes, most of us. Right? Ada's sticking her foot out. Yeah. Okay, so you can use ranges to just do operations on part of a vector. Okay, so for example, if you just wanted to search through the first half of a vector for a number, then you can say from the beginning to, and I'm going to make a variable here called the midpoint. That's the beginning plus vector size divided by 2. Microsoft. He's working for Microsoft.
Microsoft. What's Microsoft?
Yeah. They're the people who make Windows and PowerPoint and Word, stuff like that.
Ooh.
And so I'm searching from the beginning to the midpoint, and if it's not found, remember it doesn't return end, it returns this. So it returns mid if it's not found. And if it is found, you can dereference and be like, okay, we found 20 or whatever. So you can use ranges to select chunks of a vector to shuffle or to count or to find things like that. If you want to erase something from a vector, you can pass it in an iterator. So if I type in 20, it'll create an iterator pointing at 20 here using find. Searching from the beginning to the end for 20, it'll return an iterator pointing at 20. And then I can pass that to erase. And then erase will wipe that thing out and then shift the 30 left and the 40 left and the 50 left. Note that when you do that, any iterators you have are invalidated. So if you ever call pushback or popback or erase on a vector, any iterators you had before, like if you had an iterator before pointing at 40, it's now pointing at 50 because 50 just took 40's spot. And if you ever call pushback and it does a reallocate, all of your iterators pointing to the old chunk of memory, they're still pointing there. They're not pointing to the new chunk of memory. So don't keep iterators around longer than anytime you modify the vector. So that's a huge sharp edge in vectors, by the way. It's like people will do a find and they'll get a pointer to an element, and then they'll do a bunch of pushes and pops and things like that. And then later on they'll go like, all right, let's use that iterator we found to 30. It's gone now. You know, it's pointing at some random chunk of RAM. So you want to use an iterator immediately. And once you do a erase or you do a pushback or a popback, those iterators are not valid anymore. You can't use them again. You would have to do another find. Okay.
What is the synonym for work?
Work, a job, maybe. Okay.
No, like work as in you're working on something.
Doing a task. So yeah, so it's important to get familiar with the standard library. In CSCI 40, we covered the C standard library stuff like abs and max and square root and pow and sine, cosine, floor, ceiling, round. All that stuff was like from the C standard library. But we're covering the C++ standard library yesterday, or on Monday and today. So the whole point is so you don't bother wasting your time reinventing the wheel. You want to just leverage the fast code that smart people have made for you. Okay, and that's really what separates out experienced programmers from new programmers. It's like we're not any more intelligent, and it's not like maybe some are, but that's not the point. It's not like we're better at writing code, even though there's probably something to that too. What usually is the reason why an experienced programmer can get work done so much faster than a new programmer is the new programmer is like, oh man, I'm trying to figure out this code to like draw a line between 2 points. I just can't figure it out. It works for horizontal lines, but not for vertical lines. And an experienced programmer is like, oh, why aren't you just using Bessenham's algorithm for line drawing? Like what? Or Wu's algorithm? What? Yeah, it's out there. Just find it, use it, and move on with your life. Like we know what exists, and then we're like, bloop, boop, you Wu's algorithm, bloop, and there we go, anti-aliasing, bloop. Point A, point B, draw it for me, done, and let me move on with my life. We don't waste time. We stand on the shoulders of giants, right? Like that's what separates out experienced programmers from new programmers, is that we know what's out there and what's been done, and we just like, thank you, boop. And then I don't write my own sort algorithm. I call sort. You know what I mean? It's simple as that. Like I could, but I don't. Because why? Sort's good enough. If I really needed performance, and I had something that I could beat sort on, maybe, but usually not. And that just allows us to write code that's fast, it's safe, it's powerful, and it allows us to operate as a employee on like an order of magnitude greater power than new programmers, right? So you only want to be writing new code. You don't want to be reinventing the wheel constantly. Okay, so what kinds of things are out there? Sort from the beginning to the end, done. Shuffle. Random shuffle is deprecated, by the way. Shuffle is preferred. Either way. So random shuffle will randomly shuffle these numbers. And you can shuffle the first half or the second half, whatever. But just by using vec.begin plus 3, whatever. You can pick a range to shuffle. Find the max element. So there's max element, and that would return a pointer. It returns a pointer, by the way. Max element returns a pointer, an iterator, to 99. It doesn't return 99. It returns a iterator pointing at 99. And so if you want to output the value, you have to dereference it, the star. That prints out 99. And you can do min element. And if you want, you can do both min and max at the same time via this. And so min max element returns a pair of iterators. And so look at that type, by the way. This is man, that type, that puts hair on your chest, let me tell you. This is the type returned. It is a type of pair of iterators to...
I'm pretty sure there's some girls in your class.
I know, that's why it's funny. Cromwell's like, I don't think I won that. Good, then use auto instead. There you go. Right? Auto. Figure out the type from the right-hand side. This is why auto exists. So that you don't have to type pair angle bracket vector angle bracket int close bracket colon colon iterator comma vector open bracket int close bracket colon colon iterator close bracket auto instead. It's nice. And those aren't even the worst that I've seen. I've seen types that are like this long, auto.
How
Right?
long?
This long. As big as a fish. Okay. Auto is not slower. It just deduces the type from the right-hand side. So it doesn't cost any... It's as if I had typed what I had there before. So this line of code and this line of code from the compiler's perspective are identical. Okay? It's just this requires me as a human to type a stupid amount of text. That's why the good Lord invented auto. Okay? So you don't have to type those stupid stupid pair colon... And then if you want to output it, you can output dereference p dot first. Because remember, it's returning a pair of iterators. And when you have a pair, there's two things in a pair, first and second. And so we dereference those, and that's going to give us the smallest element and the biggest element. Smallest element is in first, and the biggest element is in second. So min-max element gives you both the smallest and the biggest at the same time, with the same running cost. So you don't have to call it twice. Okay. If you want to count how many 42s are in a vector, count from the beginning to the end, 42, 1, 2, 3. It'll return 3. Job interview question. Reverse the elements in a data structure. Really? Can I use the std reverse function? If they say yes, then you just call reverse, and it's reversed. Yay, you've won. One line of code. And that's actually what I would want to see a interviewee do. I want to see them be like, yeah, I'll just call reverse. Because I don't want to pay them to write code that's already been done. You're wasting my money, you're wasting your time. There's no winners here. But oftentimes they'll say, okay, kudos to you for knowing that. I'm glad you know that. And that's what I would want you to do on the job. But I want to see if you can do a for loop. And then you go, fair enough. And then you write a for loop to reverse it, or you can use the reverse iterators or whatever. So, yeah. So if they say no, like oftentimes they'll still be happy that you knew that it exists. Okay. So there's a lot of stuff in CPP reference that it's worth going over. But the point, the upshot of today is that most of these things are going to take a range. And these ranges work with vectors. They work with decks, right? I have to include deck. Double-ended queues. They're vectors. You can... No. Oh, really? That works. It's also include queue. Works also. And so I just switched it out from a vector to a deck, and you can see the thing ran exactly the same way. And let's do it over a set now. Hashtag include set. Same code. Look. And what's happening underneath the scenes is radically different. A set is a binary tree, so when it's, when you find the minimum element of a binary tree, it goes down to the left all the way to the bottom, and when you find the max element, it goes down to the right to find the right, and so it doesn't actually have to go over the entire thing like you did with a vector. To find the minimum and the maximum element only requires an order log n operation. And so what's actually happening underneath the hood here is actually quite different. But because all of these standard library functions take a range, and ranges are just a pair of iterators, and every standard library container has iterators defined on it, like what's the beginning, what's the end, what's next, then all of these algorithms work on all of the containers, with some exceptions. And the exceptions are usually lists. So in this case, I think both of these will work. So if we use a list here, linked list works fine. But some things, like if we wanted to sort the thing, we could even reverse it if we wanted to. I think that should work fine. Yep. Reversing it works fine too on a list, but if we wanted to sort it, vec.begin, it's not even a vector now, vec.end, this won't work. No. And you get the infamous C++ template substitution error message, which involves spamming the poor programmer with all of these worthless notes, by the way. They're utterly worthless. It's telling you things that it tried that didn't work. And very rarely does this actually matter, right? Very rarely does this actually matter. So what I need you to tell me, compiler, is that that line with sort doesn't work with lists. That's what I want to see. I want you to tell me you can't sort a list. Okay? What it tells you instead is that it can't find a minus operator. And the reason for that is because the sorting algorithm uses minus. And so if minus is not defined on an iterator, which is not, then it doesn't work. But the error message is completely baffling. And I apologize in advance for that. So you'd have to call, rather than that sort, you would have to call, I don't like calling this a vector anymore, but whatever, sort. Now it works. So there's a special sort function that works just for linked lists. So that's one of the, and there's a few algorithms like that don't work on linked lists, because you can't randomly access elements in the linked list. I don't think you can't sort a set either, for that matter. Not that you need to, right? So if you try sorting a set, it doesn't work for the same reason. But you don't need to, because sets are already sorted. So who cares? All right. All right. Would a C++ purist prefer the longer method if no namespace? You mean versus auto? No. C++ people use auto for iterators like almost always, because nobody likes reading or writing a type name that is 30 letters long. Like, we're just like, yeah, like goodness. Let's find some C++. Let's just look at CPP reference. Okay. CPP reference. Let's look up min-max element. Let's see how they did it. Example code. Thank you. Oh, this is how they implemented it. Let's see. Here. Yeah. So they're actually using structured bindings. Very cool. So this is a C++ 17 innovation that actually splits the pair into two variables. But you notice how they're using auto. So these square brackets here, this was introduced in C++ 17. And so this actually creates two separate variables. It doesn't return a pair anymore. Well, I mean, it's returning a pair, but it splits the pair into one variable named min and one variable named max, both of which are of type vector angle bracket int close angle bracket colon iterator. Right? You notice they don't they don't want to type it either. You know what I Here we go. Here's min. Oh, here we go. Okay, they typed it here. Okay. So yeah, for that one, I guess they used it. Yeah. Okay. So I guess they'll type it sometimes. I don't. In code, then let's look at reverse or something. Actually, that doesn't return an iterator, does it? Let's look at find. You don't need const. A const iterator just means you can't change it through the iterator, but sometimes you want to change it through the iterator. So yeah, see here, auto, right? So find returns an iterator pointing at 3, so it's going to return an iterator pointing at that element. Result 2 is going to be an iterator pointing at nothing, right? It's going to be pointing off the end, the special sentinel value over here. And if you try printing that out, that's undefined behavior. Don't ever print out the value at here, right? Because it's don't ever print the value at stood end, right? Because it's undefined behavior. It's off the edge of the boundary. It might segfault. It might not. It might print 0. Who knows? And so that's going to be a pointer to vector.end. And notice they're using the global function version of end instead of vector.end. It's equivalent. It's an equivalent thing. And then this is finding from the beginning to the end using a predicate called isEven. isEven is a function that returns true if the number is even. And so it's going to find all the even numbers, or the first even number. Yeah. This is going to find the first even number in the thing. So it's going to print out 2. Yeah. So this is going to, it runs the predicate on each value, and the first time it is true, it returns a pointer, an iterator to that number. And then you see these auto here instead of typing out that stupid type name. And the star operator to dereference the iterator and get the thing that it points to. isEven is a lambda. Yeah, this is a lambda. It's an anonymous function. It's a function that has no name. And they use auto here because the type of it, you could probably store it into type function. But again, we just use auto, so we don't worry about it. And so this is a function that takes one integer as a parameter and returns true or false based on if it's even or not. The brackets are used for lambda capture. We'll have to have a whole lecture on lambdas, or at least a small lecture on them. But you can have variables from the enclosing scope up here within here. We're not doing that, so it's just the lambda capture block is empty. What this means, it's a function with no name that takes one integer as a parameter and returns true or false based on if that number passed in is even or not. So this is a anonymous function. It's called a lambda function. And you don't need to do this. You can actually just put all of this code here, right here. And that's very common, where you just embed a lambda into a function parameter, because you're not ever going to need that function again. You only need names for things if you're going to use them again. And if you're not ever going to use it's even again, then you don't, like I wouldn't even do this. Because at this point you might as well make it a function, you know. So, I mean, I guess it's scoped, but you know, whatever. So I would actually just put all this code here. From that to that, I put all of that right here. Okay. And that is the power of the standard library. The standard library is very cool. It all fits together very nicely with you know, how iterators work, with how containers work, with how the algorithms work. It's like a triumvirate, the Triforce of Power, the Triforce of Hope. You know what that's from, Ada? The Triforce of Power. What's that from?
Star Wars?
The Triforce?
Oh, thank you. Zelda.
Thank you, girl.
Okay. Oh, wait, no. The Wheel of Time.
Oh my gosh. Now you're just messing with me. So,
no, like the one force.
Zelda's the main character. Yeah, Link. Any questions about this? It's a really neat design, and like I said, it allows you to. I am hyped for Breath of the Wild 2.
Why is his name Linkable Things?
Because he's the link to the past, right now. So the the beauty is that you can just swap out one data structure for another, and just with some exceptions, you can just have your code still work, and you can try different data structures out, and you don't have to learn. You don't have to constantly relearn things every time you learn a new data structure. Sorting is the same. Reversing is the same. Min-max is the same for every data structure. Yeah. Okay. You guys cool? You guys hyped for the standard library? More hyped for Breath of the Wild 2? What do you think? Both. That's a good answer. Both.
What?
Hyped for both the standard library and for Breath of the Wild 2.
I don't get it.
Let's go standard library. STDs. Woo! Zelda's cool also. Yeah. I mean, Zelda's cool and all. Have you heard the legend of min-max element? Okay, so that's it for today, guys. If you have any questions about the imaginary homework, it's due on Friday. Please, I'll hang out for a little bit right now. Answer any questions you want.
Wait, imaginary? Does that mean there's no such thing as that homework?
Yeah, I didn't post it on Canvas for a while, so they were wondering about it.
Okay, so the homework is just in your imagination.
Unfortunately, it's real imagination. So
No, the imagination is something one's mind make up.
True, but they're based on imaginary numbers.
Well, then imaginary numbers do not fit into the dictionary.
My daughter got really upset the first time I taught her about negative numbers, and I'm like, let me blow your mind now and tell you about imaginary numbers. She's like, what? What? You can't. No, you can't. Yeah. All right, so that's it for today, everyone. Thanks for coming out.
Hedgehog World?
Hedgehog, yeah, let's work on Hedgehog World together. And hang on, I need to stop the recording, girl. Hang on. Quatridians, yeah, let's really get excited. Okay, all right, that's it for today.
Have we got